Hello, my name is Rick Loring from LMGI. Thank you for joining us for the Solid Edge 2020 Lunch and Learn sessions. Today's topic is 3D generative design, sometimes called topology optimization. I'm going to introduce Jason Titcomb from LMGI, and we're going to take a glimpse, just a brief look at this technology. And thank you again for joining.
All right, well, hello everybody. We'll get started. You will, you can read the screen, but you'll be muted. You'll have an opportunity to ask questions at the end. So please do so. We like questions. Solid Edge 2020 portfolio is so much more than just CAD now. Actually, we won't get into everything obviously on this slide, but a lot of it Rick Loring has already covered today. A lot of excitement around 2020 we see in the community. People are very anxious to get working with it. Seems like a great release. So today, as Rick said, we're going to talk about generative design. Pretty interesting. It seems like a glimpse into the future to me, where software is helping you design your part. You still need to be an intelligent designer and tell it what the inputs are, but the software does so much for you. It's really amazing. Some of this existed already in the software and it's improved with every release. A nice improvement here is improvement when you have multiple studies. I'll show you an example of multiple studies. The colorizing, the bolding of text, just to make it easier for the user to understand his constraints and forces in the study. Tooltips are a nice way everywhere in the software actually, but they've been improved to give you information about every object that you hover over with your mouse. Data tips, as they call them. You see, actually, I think it was 2019, they added gravity so here's an example. Some of these slides, they're right from our update training, which is kind of good. We may not go into detail, but in the replay, you could always pause and read the detailed information that may be on these slides. So gravity was added, displacement, still looking for really cool demonstration of displacement, but so it's a lot like fixed, obviously, but you can specify an allowable range. So it's not completely fixed, it's allowed to move a little bit. But this is kind of a cool addition, being able to create multiple load cases. So that's what the first demonstration is going to be. I didn't completely understand this when I first saw it. The idea is that you have a load on a part that may be in a certain direction, but it actually may take loads from the same areas, but it maybe takes loads in different directions. The same points on the part, but it may be a landing gear that, as it's taking off and when it's landing, it takes forces from two different directions, that kind of thing. So you can create these two separate load cases. You used to have to make them all in one study, and they would kind of cancel each other out a little bit. This allows you to have more than one. So that's what this first demonstration is. We're going to open up a little part. It's the one that you just saw in the previous slide. Pretty easy to take a look at. We've got the generative design pane open, and the generative design tab is active. You can obviously see the improved colorization in your study to help you, just visualize all your inputs. Now this has already been done. So you see that here's one force pointing upward, and then there's another one pointing downward. So it's a little hard for the software to generate the most optimal design when they're kind of combined into that one load case. So that's why they've added the ability to make separate load cases. So again, this has already been run, so we can hide our design body because you may or may not know, ultimately the software creates a new construction body. So this has been run. The stresses are interesting, but again, this is not necessarily FEA. It's because it's going to create the design, so it's a little bit like FEA. It's kind of interesting. So this is the design that it came up with, but we can improve on this by creating a separate load case. Also, actually, the displacement over there, that's where the new displacement constraint is, and the new gravity load. I guess if you had a long span part, you could use the gravity to help you create an optimized design for that. So this is really pretty straightforward. We're going to take the constraints that were already created in the first load case, and we're just going to copy them down to the new load case and just delete them from the original one. That's pretty much all there is to it. There's also a way you can right click and duplicate a load case. But really from here, it's just a matter of regenerating, which is the process of, the magic of the software creates this design based on your inputs. The time it takes can be substantial. So you see the webbing on the right, it's filled in a lot more. The stresses are probably similar as they would be, but it's a way to essentially give the software more inputs. So that's very cool addition to the software. Now another option here that's available with the Pro license, different ways to reduce the mass. You can obviously adjust your factor of safety if you want to, and use that as input. But this, being able to create a more simplified design that may be machined with conventional methods instead of an additive type process, like maybe you just have milling machines and your task is to reduce the weight, but yet maintaining the factor of safety. This ability to make an extrude, which is more of a prismatic, at least in kind of one direction, something that could be machined maybe in two operations on a milling machine. So this next demonstration is kind of a quick example of that. This is a simple part. Maybe it was your job, your boss gave you this part and said, looks like we have an awful lot of material here. It's kind of a waste of material, or maybe he asked you to reduce the weight on it, but yet still keep it safe. Any of those scenarios would work, and the intention is that we're still going to manufacture this with kind of a conventional process. So we're going to apply loads, and the typical fixed constraint running with the defaults. So these two areas on the model would be considered, constrained by some other geometry, and you can give it a diameter. Obviously, you see in the inputs. And then a couple of settings here are important. The direction that we want the extrude to happen in. Maybe I'll go and turn on the coordinate system. So if I turn on the base coordinate system, you can see that the y axis is the axis that we want the extrude to run along. And then the overhang, also so the plus or minus is going to be kind of a symmetric type extrude, and then the overhang, we obviously don't want any overhanging material in the areas that it's going to reduce the weight. So then it's just a matter of generating, and you can experiment with the quality if you want to, and how much weight you'd like to reduce. So for example, if you maybe was shooting for a certain weight target, we could use the slider or key in some values for that. And then it's just a matter of letting the software do its work. So I'll bang in 19 and let that let that process that. So, yeah, it takes a little processing time, but you can often just go do something else. The benefits are amazing. Sometimes the progress bar seems like an eternity, but if you were changing this design so that years to come, as you produce hundreds or thousands of these, you're saving material. It's truly worth a few minutes of a progress bar. You'll see in the later slides, there's actually some offline kind of automation that you can do. So that's an example. That's what the software came up with. So this could be certainly machined with 2 operations on a 3-axis milling machine. So much simpler result using the extrude. I think that should be pretty good. Material spread is a cool option. You can actually see the variations on the results that you can get. It's kind of, think of it as tweaking the algorithm, I guess. The strut-like structures. I won't go through all the steps here to generate both of these. I did want to show that you can have multiple studies within your generative design pane, which is pretty nice. You may want to generate a few studies, come up with different scenarios, and then meet with the team and see what they like. So all the information is preserved. All our forces and constraints are preserved in that study navigator. And I think I'll just turn off the design body and turn on the results from the first study. And these are the settings that were used. It retains all of these in the study. So if you wanted to tweak that particular study and redo it, you could. And then we'll just turn that off and check out the other study. If you double click it, it becomes active if you wanted to make some edits to it. And so there's what the software came up with to support those constraints and that we put in, but using the strut-like structures in its algorithm. So that's really all there is to it. It's super easy just to try and enjoy the results, and use it for inspiration in your designs, or actually use it. And this is just a lot of information on this slide. Again, if you ever watch the replay, but you can batch out the generation results. Thought we'd throw this in, even in a generative design model, not just an imported STL or a scan file. You can run Remash, and there's benefits there. It helps the software understand better what should be a cylinder and a plane and things like that. So next up, a little bit of additive manufacturing. So there's this is a whole new 3D print tab that is in the software. Setting planes for visualizing the design, deleting voids are things, voids are a problem with some additive manufacturing processes, as are thin walls and overhang situations. It depends on the process, but these are tools that you can use to help you prepare for the additive process. Apparently, it's a problem. Well, threaded holes also, the software will model the physical thread for you. You'll see that in this coming demonstration. Depending on the process, it'll get you a really nice thread, or maybe a thread that's pretty close, and you might have to run a tap or a die over it, but at least for a larger thread, it may be good enough. So a lot of service bureaus have to reject designs because they cannot be manufactured. Maybe there's some thin areas or the overhang. And if you knew this beforehand, you'd prevent that rejection from the printing house if you have it done outside. Anyway, so this is our hero design set. I've gone ahead and used a model view to help me get right to the part of interest. This has already been optimized with the generative design for additive manufacturing, so it's kind of a weird, kind of looks a little different than most machine parts. And we'll take a look at some of the tools we have in the on the 3D print tab to help you understand how the additive process. So let's see, here's so obviously the generative's already been done. There's all the study information. The 3D print tab, what do we want to look at first? Maybe the overhang. So this part, it's laying down on its side, it appears to be, so there's going to be a lot of overhang, so we'll come back to that. Thin wall, certain additive processes can print really thin wall areas, and others, they'll fail if the areas are too thin. So this is a way that you can analyze your design to point out these thin areas before you attempt to print it yourself or send it off to a service bureau to be printed. So kind of do it up front before we hand this off to any other downstream processes. So that's very cool. Jump back to the 3D print tab here, take a look at you may want to reorient this. Before we take a look at the overhang, we probably want to reorient it as it would sit. So we're seeing a mock-up of the print bed, and you can certainly move it. Usually rotating apart is something you almost always have to do to get it to sit in the print bed the way you want. I'm just going to bang in something close to 90 to illustrate that there's a great feature to reorient by use the settling process. So it kind of finds the flat area, and kind of an optimized rotating capability that will find the best orientation. Maybe if you were going to print 40 of these at once, this would be very useful to get them all kind of nested in there, just so. So now when we go and check the overhang, we'll be checking the overhang in the orientation that we just set in the print bed. So this will make a little bit more sense. If you have a 3D printer, you probably know the issue we're talking about here. If you don't, some of these 3D printers, like the MakerBot that use an extruder, they're not good at printing a ceiling because the material just tends to drip down from the ceiling. So you kind of want to have a 45 degree or something like that. And then certainly we can just export it, but now we can export as 3MF as well as STL. 3MF supports a little bit more information like colors and things like that. So if your printer supports those, that's very nice. It's just kind of a more modern accepted format for 3D printers. We've got another model view here. I'm going to apply that. Take me right down. So this little base once was sheet metal. It looks like sheet metal. The story is that the team decided to make this a 3D print, and we're going to take a look at it to show off some more of the tools on the 3D print tab. Being able to identify a void is kind of important. If some printers utilize a powder material and they have a powder bed, and this area would just be filled with powder, it's kind of a waste. It's not really good. If it's you'd be better off if that void was just gone. So the software can find that, kind of magically find that that's a closed little cavity, and just delete it for us. Nice preview of just the voids there, and then when you're ready, just hit the accept button and it will remove that. You see a delete face down in the simplify bar, so it's kind of a quick way to remove those voids. Now I think the designer should have applied a thread to these little bosses. Certainly we can do that in Solid Edge, been able to do it for a long time, but the new addition, when you're creating either a thread or a hole right up front, you can, I probably should make this metric, I guess. So you can decide to have that model a physical thread. And you can see it picked up the M7, of course, nothing too new there, but the ability to model that as a physical thread is very cool. I think I'll tighten up the quality of the view a little bit so it looks a little, you can see that's a perfect thread based on that M7 classification, and we can just do that for the rest of them. So we're kind of combining a couple things here, just reminding you that you can add threads to a cylinder, of course, but then when you create a hole, you'll have the option, and even when you edit a hole, you'll have that option. You can toggle that later if you want. It's not kind of a one-time thing. You can turn it on and off at will. I think this is something I would probably do at the end of the design process, just before we send it to 3D print. So I've added this really nice command that will do it globally. You don't have to go and find every hole and click every hole. The software is just going to go find all your fasteners. It knows the thread data. Produces a nice report at the end, just so you know that, if there were any issues, I can't imagine what one would be. We pretty much know everything about a threaded hole. And then they're all model threads. I've actually used this for home projects with my little MakerBot. It's kind of nice to have that thread already there. You don't have to go get a tap. And of course, you can save it out as 3MF. So yeah, awesome addition to be able to have physical threads, delete voids, lots of tools for the additive manufacturing. So there we go. Hopefully we've got some questions. What do we do, Rick? Ask them to put in
Yeah,
chat
there's
window?
only one question came up, which so far, which versions of Solid Edge come with the Generative Design software? Not the Pro add-on, just the basic.
Yeah.
And I think that's Classic and Premium.
Oh, very good. Any other questions?
Any other questions? We'll have them emailed to us, and we'll go from there.
All right. Well, thanks everyone for attending today, and have a great afternoon. And hopefully we'll see some of you again in our last session on Thursday. So have a good day.